Okay, welcome everybody to my talk, Concurrency in Enterprise Java. My name is Alexander Heusingfeld. I'm a senior consultant at a German company called innoQ. And I'd like to talk a bit about concurrency today in some enterprise projects that I was involved in. I don't know how many of you actually, wait a second. How many of you actually know this quote? I saw it quite recently in a post on DZone by Lukas Eder, and I have to say, unfortunately, it happens to me every now and then that exactly this situation comes up in my enterprise projects or in my enterprise customers. So typically, when there's a lead developer, I hear things about, okay, what are we actually talking about? Oh, seems my clicker is broken. Anyway, there ain't no fuss about concurrency, right? If I want to do some things concurrent, all I can do is create a new runnable, implement the stuff I want to do in the separate thread and in the run method, create a new thread with this runnable, start the thread, and I'm finished. It's asynchronous, it's perfect, it's non-blocking, it's fine. Well, turns out we often end this way. So what are the actual issues with this kind of behavior and this kind of code? Well, first of all, in my point of view, there's no management of the thread lifecycle, right? When I kick off a new thread, what happens with the thread? As a developer, I have to take care of it. I have to take care of how many threads I actually create and what happens to them if the execution fails. I have to take care that they actually don't block my JVM from shutting down, and there are plenty of other things that I need to take care of to be able to actually operate my application. And this, for example, includes monitoring. And if you ever try to monitor the actual state or the actual well-being of threads that you kicked off this way, you know how tedious and close to impossible it is to actually provide meaningful metrics for monitoring. And of course, in Java EE applications, you also have the problem that the context is not propagated to the new thread. Okay, so what can we actually do about this? Have we got alternatives for this? Well, yes. In my projects, I often see people using java.util.concurrent, which is, as you might know, the JSR 166, which was refined multiple times since Java 5. But it provides some great convenience. And what I'm talking about is, you probably know, the Executor services. Executor services are a real pearl in my point of view because they provide convenience methods in terms of don't make me think or don't make me write boilerplate code. And the reason why I like it is that they prevent many simple mistakes. When I have to create a new thread pool to manage threads, I can make very, very, very many mistakes, and therefore I like the convenience that the executors actually provide. But still, in a Java EE context, they are missing the platform services like dependency injection, persistence, transactions, and security. And that is why JSR 236 was called into life in 2003, actually. Then kind of fell asleep over the years, but was restarted in 2012. And now it brings some of the features of Java util.concurrent to your Java EE applications. So the main target of this is actually to provide a standard way to get a container managed thread, as they call it. So that means that your context is propagated into new threads that are created. That means that the class loading, JNDI namespace, security identity, and so on are propagated to your threads. And of course, management and monitoring of those threads is also an important issue. And we certainly want to know how many threads are actually running in our production environments, because if you think of how many threads you can run on modern laptops, like, I don't know, I have a virtualized 12 cores on this machine, and on production I might be running in a virtual environment which only has one CPU, so you certainly want to adjust this. But why have I been interested in this? Well, it turns out I first got into contact with JSR 236 when I was actually looking into something completely different. I was actually looking into a project of my customer who had some stability issues. There were some really silly bugs inside the application that were the results of workarounds for his Java EE applications. Meaning the developers used java.util.concurrent, and they tried to implement some workarounds to actually propagate parts of the Java EE context to their threads. And sometimes this worked and sometimes it didn't. So I was actually looking for some way to implement the patterns of software stability. Has anyone heard this term before? Okay, probably in a second. The patterns of software stability are common patterns like timeouts, for example. A timeout, I guess everyone has heard of a timeout, right? That's basically that you say, when I execute a request, I don't want to wait forever. I, for example, want to search for a product and I don't want my customer to wait more than 3 seconds. After this, I fail the request and, for example, send back a fallback value. Another thing that is well known are bulkheads. Bulkheads are used to separate an application. So, for example, I can say, okay, if my product service isn't available, this shouldn't infect or affect in any way my front end. A pattern that I really was looking into was the circuit breaker, which means I want to fail fast if an application is not available. That means if I make a request to my product service in the backend and I notice that my requests keep failing, then I open a circuit, as we know from real life, which means there is no way to send any requests to this service again. Why would I do this? To let the other service recover. Because it doesn't make any sense if this service isn't available at the moment. Why would I want to hammer 1,000 more requests onto the service? Give it a few seconds, let it recover, try again. If it's fine, then let all the requests go through. That's basically the circuit breaker. Another one would be steady state, which means I don't want to clutter my system with resources. I want to free resources that are unused. That could be compared to the garbage collection. And now I guess you probably heard of this guy. Michael Nygaard wrote a book that is called Release It, and maybe one or two have heard of it. He very well describes those patterns and some more in detail, and I can really recommend this to any one of you for getting your applications more stable. So as I said, I was actually looking for implementations of the circuit breaker, and therefore wanted to have a look into thread pools and threading in Java EE. And actually, that is what I found. Honestly, from the outside, when I first looked at it, it looked like a really, really small JSR, because I only saw like 4 main classes that are there. and I somehow underestimated what is inside, and now I want to show it to you. So first thing you need, if you're into concurrency, is a thread. And how do you get a thread? Probably by using a thread factory. So as you know from Java SE, you can either create a new thread by calling the constructor, or you can use the thread new thread method. And the ManagedThreadFactory is actually extended from the Java SE thread factory. It has the same API as thread new thread, so this new thread method is available. The difference is that the thread returned by new thread is a so-called manageable thread. That means that it has a new method, and this method is called isShutdown. We will get to this in a second. Unfortunately, everyone who has done concurrency in Java SE before knows the isInterrupted method, and this method is not available anymore. But as I said, we'll get to that in a second. What I can do with this thread factory, if you look closer into your Java SE executors, all of the methods that are actually there do accept the thread factory as a parameter. That means all of the executors methods that accept the thread factory can actually be used with a managed thread factory. And that means all the functionality that is there in Java SE is finally available in your Java EE application. And how does that look like in code? So you can see, excluding the first line, this could very well be Java SE code. But it actually isn't. This will very well run in your Java EE application. Unfortunately, there is a downside. As I said, the JSR 166 has been refined multiple times since Java 5. And one of the greatest achievements, in my point of view, was the fork join tool. This is not supported by the managed thread factory yet. But if you look at this code, and you ever implemented concurrent code, you will know that this my task will actually have to check whether it has been interrupted, for example, when the JVM has been shut down. But as I mentioned before, the isInterrupted method is not available. It will actually throw an exception. So what are you supposed to do? And therefore, to explain this, I want to look into the implementation of the my task. What you actually have to do is, you can see in the while statement, you will have to check the isShutdown method. So you call the current thread method, cast this one to manageable thread, and call the isShutdown method. That's the way you are supposed to do it. And of course, as you can see, transactions are not propagated into new threads. Seems awkward at the first step, but logical on the second. But the user transaction is very well available, and that actually works. This code is, by the way, taken from the Java EE samples project. I don't know how many of you have heard of it, but there are some samples for concurrency utilities already, and I'm about to provide some more in the upcoming days, I hope. Okay, the next class that will be there. Sorry? Yes. Yeah. Yeah. That would be, yeah, it's simplified. Yeah. Sorry, the question was whether we should check whether the user transaction has been marked for rollback. Of course, in production code, you would definitely do this. Yes. Good one. Okay. The managed executor service. Again, convenience as known from Java SE. In my experience, in my scenarios, it was the class that I used the most. The difference to the thread factory is that the container context is captured when you submit a task to the executor service. The thread factory also captures the application service context, but at the startup of the application server. That can make a difference depending on where in your code you actually inject or submit a task. The managed executor service extends the Java SE executor service. There are really no differences in the API. So you have the methods for submitting or executing tasks in your Java EE environment. It's available via JNDI lookup or the @resource annotation. And of course you can submit runnables or callables. But again, lifecycle methods are disabled here, and this affects the await termination, is terminated, is shut down now methods. So when you call these, an illegal state exception will be thrown. As I said, it seems awkward at the first step, but it actually isn't, because the executor service is managed by the container and shouldn't be managed by you. And that would be a sample implementation of the, or a sample usage of the managed executor service. Again, very, very simple, doing something in the background. What is nice about the executor service that I didn't know before is there's the invoke all method. That means you can specify a list of callables or runnables to this invoke all method, and it will add all the tasks to the executor. And what is specifically nice about this one is that you get a list of futures in response, and the list of futures is actually sorted the same way as the list of callables that you submitted, so that you can do the matching. In my point of view, a great scenario for the managed executor service would be the async servlet. So a very simple example of getting the async context and then creating a task that will actually do something in the background to free the actual HTTP thread that will handle the HTTP request. The next one would be managed schedule executor service. Scheduling tasks to run after a given delay periodically or at custom schedule. Seems boring because it's as expected. Managed extends the managed executor service, extends the schedule executor service. We know from Java SE, but there is an additional method to schedule tasks with a trigger. And this trigger is something new that has been added for JSR 236. And we'll get to this in a second. So there's a simple example for the schedule at fixed rate, which means the task that my runnable task here will have an initial delay of 5 seconds and will then run every 10 seconds. And this task will be repeated until it throws an exception. The cancel method of the feature is called, or the executor is shut down by the container. The trigger, in turn, provides a way to be more flexible and provide a custom execution schedule. And we here have a very basic example from the Java EE samples project again. The idea of this my trigger is that we don't want to run a task after a certain date. So what happens is that this trigger is called by the managed schedule executor service, and the get next run is the get next runtime is called to schedule the task. And this get next runtime, as you see, gets the last execution info, which contains information about the last execution. So, for example, the date, the point in time when the last execution happened. and it also contains the task schedule time, which is the point in time when the task has been added to the executor service. And as you can see here, what we do is we simply check whether the task was added to the executor service before the configured fire time. Whether the task was added after the configured fire time, and if this is the case, we won't run the task. The skip run method is called before the actual execution. The get next runtime is called after the execution, so that you have, let's say, a very specific way to actually check before and after the run of your execution of your task, whether the task shall be executed again. So you can stop the next execution and handle properly mistakes in the previous one. Yeah.
In a cluster environment, it will run on each node of the cluster, because often that's not specified in the GSR, and that leaves space for interpretation.
I cannot remember that I read anything about clustering in the specification. Yeah.
Often they forget about clustering.
Yeah, that's probably because the question was whether the clustering is specified in the specification of JSR 236, and I don't remember. But I certainly can look this up. Sorry?
No.
It's not? Thanks, Antonio. Okay, the fourth one would be the context service. That is used and defined as for creating contextual proxies of object instances. What that means is that the context that the current execution environment has is captured on the creation of this context service. So the objects that are encapsulated in this context service, which is a dynamic proxy, will actually afterwards be run with this context. And of course, the examples again would be the persistence, EJB, security, and so on. And this is customizable through execution properties. For example, the execution properties are available on the managed task interface. So there are, for example, use transaction of execution thread and other ones. And to showcase what you can do with this, there's a small sample. Imagine we have a message processor that needs some EJB to run and also needs an entity manager. So what we can do is to wrap this processor inside a contextual proxy. Then we get this proxy object back, which wraps our processor instance. Then we put it into a cache, for example. And at a later time in a different thread, you can get this processor and do some work. And you don't necessarily need to have a context in this separate thread. So you could very well just go with the with a normal thread pool or with anything without paying attention to actually having a managed thread there. But the worker, meaning the proxy object, will still have the context of when this has been created. And this is considered to be used for advanced use cases like task listeners, for example. And talking of task listeners, this is the interface that is available also in this JSR 236. A task listener, as you can imagine, is to be used with a certain task so that you can react on certain events of this task. So you will be notified, for example, when the task is starting, the task has been aborted, or the task is done. And what is specifically interesting, what I have used in one of my projects already, is this task aborted method. Because what you get there is not only the task itself and the exception, but you also get the managed executor service and the future. So in this task aborted method, you can define what you want to do with this task. You can check what the exception was and decide, for example, that you want to resubmit it to your executor service and not fail. But of course, you can also decide to fail. One thing that needs to be pointed out that we stumbled upon is that this task done method is always called. So even if the task has been cancelled or has failed, so the task aborted has run, and afterwards the task done will also be run. And how can you use this managed task listener? With a convenience class that is called managed executors. This is, so to say, the pendant to the executors class in Java SE. And you can actually add a task listener to a certain runnable or callable before you submit it to a executor service. Another convenience method at the very bottom. Remember that you had to, inside your thread, you had to check the is shutdown method of the thread, and that you had to cast on manageable thread and so on, which looked a bit ugly. And the managed executor service is like hiding the ugly stuff, and you can simply call the managed executor service is current thread shutdown to avoid this stuff in your code. Okay, enough for the theory. The question was how for us, how do we configure and actually monitor this? And that was, we first of all looked into Glassfish. That was when it was about the time when Oracle decided to drop the enterprise support for Glassfish, and the customer whose project I was on decided to not go with Glassfish, and therefore we checked out Wildfly. And I downloaded Wildfly 8, was I think beta 2 back then. Started the server, looked at the UI and thought, okay, where are my managed executor services? Well, it turns out there is no UI for it. There's no way to configure this on the UI, and there's no way to add entries via code. The specification only defines that application server vendors need to provide a default configuration for their thread factory, for the context service, for a managed executor service and a managed scheduled executor service. And what this looks like, you will see in a second. So what we actually did is check out the Wildfly command line interface. And this is a command that you will have to use to create a managed executor service, as you can see here. So it's in the EE subsystem managed executor service, and the name of this will be async HTTP MES. I shortened this to not get into conflict with any naming constraints. And what you can see here is that you, while creating this, you configure it to have a certain number of core threads to start with. It has a JNDI name that you can use to look it up. It uses a context service, which, yes, is a reference to another configuration inside that has to be there inside JBoss. You configure a hung task threshold, which means this is the so to say a timeout for a task when it will be considered cancelled, or yeah, when it will be cancelled afterwards. So when it will be considered hung. You have the thread factor, which is again a default, a reference to the existing configuration. You have the maximum number of threads at the bottom, which here is 500. You have a rejection policy, what to do if your queue, which is configured to 50 entries, is full. So the executor service cannot accept any more threads. And all this you have to specify on the command line interface, which, as you have to find the exact matchings, can be somewhat tedious. Okay, we thought, let's look at the monitoring. Well, monitoring, well, there is a way to export the configuration and check the configuration via the command line interface, which was interesting for us because we wanted to script this anyway. But that seems kind of poor man's access. So this really is too complicated. Shouldn't there be an easier way to at least create those commands? Well, it turns out there is. It seems that the Wildfly guys thought about this issue and created a UI client. And what this UI client does is it lets you navigate through the subsystem tree and create the command line interface command that you have to execute on your command line and that you can put into your scripts. As you can see in the top of the window, this is exactly what you have to specify in the command line, but relax, you don't have to copy this and paste it to the command line. You can actually just submit it and we'll be fine. Okay, but still, this is not going to work for real monitoring, right? Of course, all the stuff will be available via JMX, and so you can actually check it via JConsole, or as I did, via a Visual VM. You can also edit the values there. You can check the metadata of the stuff. You can execute the operations there. But if you look at this is exactly what I was referring to. This is the let's say the untouched Wildfly, and this is exactly how the specification tells the application server vendors to handle it. You cannot actually determine by the name whether this is a managed executor service or a thread factory. It's not possible. So my recommendation definitely is provide your own defaults and use meaningful names. Okay, are we fine? Is this all we need? I mean, okay, we checked why this is reasonable to use. We checked how we use it in the code. We checked how we configure it, how we monitor. Well, turns out there are some gotchas, and I think I promised in the abstract to tell you something about the stumblestones in our real life projects, and I tried to pick out some of the stuff that we made us stumble. The first scenario would be called the single executor service. And this would be this scenario code that we found. Can you imagine why this code could be an issue? We have the add resource annotation there that injects a managed executor service. If I imagine this was used inside a servlet to kick off some actions from incoming requests. Sorry? Yes, this is the default that has a hung thread timeout, but the question that we should ask ourselves is this really only used here? So if we submit the callables and we have, I don't know, thousands of requests coming in, and we use this managed executor service here, and for reasons of resilience, also for our backend calls, this will really overload. So the recommendation instead would be use a specific managed executor service. When you have a certain use case, you know what you want to do, and you know what you want to use. Therefore, be specific about what you want to do and make it readable in your code. That would be the JNDI name. As far as I know, the simple name, so service request executor, would also work. The second example was called the queue that queued. The executor service provides no access to its queue. And we had a scenario where the queue of the executor service got filled with the same entries again and again and again. Unfortunately, the default queue value was set to max integer. I'm not going to discuss this fact, but you can imagine what happened when a developer added a few thousand objects to the queue. We got out of memory issues in our server. So what we did here is implement a way by using our own thread pool executor to be able to check whether the queue already contains a specific task. To do this, you of course have to implement the equals and hashcode method on your runnable, and then you can use the contains method. That was the first step, but the second issue was right after this, because of course the contains method locks the queue, which is not so great for parallel checking out the tasks from the queue. The third topic is called a self-overtaking job. And it turns out that with the new competences we have, there comes a new burden. And we might easily enter the domain of batch processing without actually noticing it. Sample code for this would be manage scheduled executor service, schedule at fixed rate. So you have a delay of 5 seconds, and after every 10 seconds, a new execution is started. This might easily overtake itself, because what about if the my runnable task takes longer than 10 seconds? So if your task takes longer than 10 seconds, a new task, so check the start times. The first task will be started at 5 seconds, next at 15 seconds, 25 seconds, 35 seconds, and so on. And you can very easily get multiple running instances of this task. And if this task is not self-contained and accesses some external resources, you can actually have some very weird problem in your production environment. Because, for example, if the execution time depends on other resources like the speed or the latency of your network or your database, then you will have different results on your different environments. A topic that is not so important for the JSR 236 is know your rejection policy. I didn't mention it before, but the rejection policy for for JSR 236, so the managed executors rejection policy, can either be abort, which means if you cannot accept the task, throw an exception. So that means either the number of running threads is full, or the queue is full, or both. And the second would be retry abort, which means when the queue or the core threads are full, retry once and then throw an exception. So you cannot fail gracefully. The competition from Spring uses the policies that are available on the Java EE7 thread pool executor. I personally don't know why these haven't been taken into account for the for JSR 236, but we definitely ran into scenarios where we wanted to say, okay, a discard policy makes more sense here because we just don't want to fail the processing here. A discard policy basically means that if my queue is full and I cannot accept any more tasks, just drop it. It doesn't matter, it's no problem. And as I said, managed executors cannot do it, unfortunately. The fifth example is Go Java 8 and Shine. When I first heard that Wildfly will be compatible with Java 8, I was like, yes, finally, perfect. I finally have the ability to combine the executors with the lambdas, the streams, CompletableFuture, and so on. Well, are we sure? A simple example of Java 8 Streams API would look like this. So what I do is I get a list of product URIs. I open a parallel stream, which means I try to process it in parallel. And I map my product URI on the result of a resolve products method, which basically does a HTTP call to retrieve the product. Afterwards, I call the join method to get my products. So imagine a list of product URIs inside a shopping cart. You try to resolve the products from a different system. You run the different requests in parallel. Afterwards, join them, extract the body so that you actually have the product, and then join it together to a product list. The important part is this. Under the hood, the parallel stream will use a fork join pool. Unfortunately, the fork join pool is not compatible with the managed threads. That means the fork join pool doesn't extend the other thread pools that you have in Java SE, and it is not at all covered by JSR 236. And though I would actually love to have the fork join pool because of, for example, the work stealing available, there is no way to do it straightforward. Another issue is that internally the fork join pool uses runtime.available processors to get the number of cores and therefore determine the parallelism, which is probably fine in some cases, but it might be an issue. If you imagine that each fork join pool will do this, and you not only have multiple fork join pools inside your applications, but you have multiple JVMs running on the same system, and they all expect that all of them have the same, or all of the cores of the system available, this will result in a mess. And we actually had this issue with a customer who tried to run multiple instances in numbers 8 instances of JBoss EAP7 on a machine. And I have to admit they didn't configure the JBoss properly. Instead, they used or relied on the default configuration. The auto configuration of JBoss also uses the runtime available processors to check the parallelism level. Okay, if we cannot use the parallel stream, of course we can use the streams API and the we can use the completable futures. But what if we don't have Java 8? Well, let's try with Guava. What happens? I just use a managed executor service again. I decorate this with a listening executor service. This is a class from Guava, obviously. And then I submit a callable to this service, which returns the ListenableFuture. And what I then can do with it is that I can actually add callbacks to this future. That means a very basic callback handling of the future's result. And as you can imagine, on successful execution, the product will be handed over to the onSuccess method, and in the case of failure, the onFailure method will be called. Anything else? Well, to be honest, when I first looked at the configuration, that sounded kind of familiar. What you see here is not the configuration for JSR 236, but instead for a executor service that was implemented by I think it's a Dutch software company called Xebia for Spring. That was back in 2011. If you want to compare it with the Wildfly configuration, in my point of view, it looks very familiar. And that is actually how this service looks in Visual VM. So if you don't have Java EE7 available and have a Spring application, you might want to look into this Xebia Management Extras, which is quite nice, I remember. Well, I haven't used it since 2011, but was quite nice then. Okay. I mentioned Hystrix at the beginning, I think. Hystrix is, let's say, the default answer of most people when you talk about resilience. And I had to mention it because I actually started with the introduction to JSR 236 because I wanted to have some resilience. And Hystrix implements many of the stability patterns I mentioned, and it's famous for its circuit breaker. Unfortunately, they have their own implementation of a thread pool that is called Hystrix thread pool, and there is no straightforward way to submit a managed executor service or a thread factory from JSR 236. There are some workarounds for this. I saw a experimental implementation for WebSphere, but I decided to not look into this further. So the summary for me for JSR 236 was that it kind of provides a good mix of convenience and flexibility, but still has a lot of potential for optimization. So there would be, I definitely want to create executor services from the code. Yes, they have to be managed by the operations team, but why shouldn't I be able to actually create them inside my code? Another issue is that you saw that you can change the values via JMX, but there is no validation or constraints. Maybe they have been set to these values for a reason, because my application expects them to be in some kind of relation, and if they are changed without checking the constraints, my application might crash. So I actually would like to have a kind of validation for the properties. I already mentioned the available processors stuff. The parallelism using this for parallelism is deceptive, especially when you think of the virtual environments where you might only have one CPU core. And one wish that I would have is to finally be able to use fork join pool in Java EE, so you can take the full advantage of the work stealing. I added some links. As I already mentioned, the JSR 236 spec and the Java EE7 API docs, and also the Java EE7 samples project that I mentioned, which has some great sample implementations for the JSRs in Java EE. Of course, not only concurrency. And if you want to go with Wildfly, the specific subsystem configuration can also be found in the Wildfly docs. To conclude further, my first interest in JSR 236 was kind of torn down, but not so much that I wouldn't love to discuss this any further, and that's actually why I handed in this call. That I would actually love to hear your opinion on JSR 236 or on concurrency and enterprise Java in general. So, if you have any questions or would like to discuss this further, I'm really looking forward to this. Thank you for your attention.